All right, today we're talking about defining and evaluating logarithmic functions. This is day 2. So we're going to do more of the evaluating today and look how that process looks. But we're going to use yesterday's techniques to do so. Evaluating. If f of x equals the log base 10 of x, we're going to find these values, which means we're evaluating. We're going to plug these values in for x and find out what it is. So first, we're going to change everything to an exponential. So f of 1,000 has to equal something. It's going to equal to y. So if we plug in the 1,000 to our function up here, this 10 stays, but we're going to plug in the 1,000 for x. So f of 1,000, that means we're plugging it in for x, equals y. Then we're going to rewrite it. So we have log base b of a equals x. We practiced this yesterday for a reason. Now, that also gives us that base b is 10, a is 1,000, x is y, and we're going to plug that in. So we get 10 to the y is equal to 1,000. So we need to write these to have the same base. So to get 1,000, that's 10 times 10 times 10. That's 10 to the third. So I'm going to say y, 10 to the y equals 10 times 10 times 10. So 10 to the y is equal to 10 to the third. Well, if the base is the same, then the power is also the same. So y equals 3, and voila, you're done. We're going to try it a few more times, make sure you really have it down. So here we have f of 0.01 equals y. So we change it. We plug this in for x into our function we were given. This is y. And we are going to rewrite this as an exponential. So our b value in this case is still 10. Our x value is y, but our a value is now 0.01. This as a fraction is 1 over 100. 100 is 10 squared. Now, to move this from the bottom to the top, I rewrite that as 10 to the negative 2. Since the base is the same, that means the exponents must be the same, so y equals negative 2 in that case. And then our last one we're going to evaluate. F of square root of 10 equals y. We have the log base 10 of the square root of 10, because remember we're putting the square root of 10 in for x, equals y. Now, we have the log base b of a equals x. So over here, our b value is 10, our x value is y, our a value is the square root of 10. And remember, I need to write it with 10 to a base. Well, if you remember back to our previous unit, that's 10 to the 1/2 power. So y in this case is just 1/2. Now, we have a word problem we're going to look at. Talks about the acidity level of, or pH of a liquid is given by the formula pH equals the log of 1 over H plus, where H plus is the concentration in moles per unit, or moles per liter, of hydrogen units in the liquid in a typical chlorinated swimming pool. The concentration of hydrogen ions ranges from 1.58 to 10.8 moles per liter to 6.31 times 10 to the negative 8 moles per liter. So this is our range we're looking at. What is the range of pH for a typical swimming pool? So they're given the concentration of hydrogen. We want to change it to pH, so we're going to use our formula. Now, when we use our formula, we're going to simply plug in the hydrogen. These are the hydrogen values. So we're going to say that the pH is equal to the log, and it is a base 10, because whenever it's not given, it's base 10, of 1 over 1.58 times 10 to the negative 8. And we need to convert that. We need to figure out what that value is. And so on our calculators, this is like, if it's the negative 8, this is like saying log base 10 of 1.58 times 10 to the 8. You plug that into your calculator. Your calculator does great with base 10 problems. And you're going to get an answer that is about 7.2. You should find a log button on your calculator, type in this number, push the log button, you get 7.2. If you're confused about how to use your calculator, we'll talk about it in class tomorrow. Now, we do the same thing, but we're going to use our other value. So the pH is the log base 10 of 1 over 6.31 times 10 to the negative 8. That is really just the log base 10 of 6.31 times 10 to the 8th. Negative moves it to the top. When you punch that into your calculator, you get about 7.8. So the range of the pH for a swimming pool goes from 7.2 to 7.8. pH range is for a typical swimming pool. And you have a word problem. And this should show up in either chemistry or some physics. Hopefully you guys have seen it a little bit in chem. If not, maybe you will soon.